Jai Swaminarayan. This is Professor Urvish Mewada, Head of the Department in the Electrical Engineering Department, Sri Swaminarayan Institute of Technology, Gandhinagar. I am the subject matter of Interconnected Power System subject, which is in the GTU 7th semester. The subject code for Interconnected Power System is 2170901. This is the second lecture for chapter number 2. In first lecture we have studied about explanation of graph theory and primitive network. Now today we will study the topic number 3, bus incidence matrices. Now why this bus incidence matrices are important for the calculation of the power system networks, because uh, if we talk about a bus, then bus is a conductor on which we have so many incoming and outgoing lines of the conductor. So due to that we need to calculate the contingency of the power transfer from the transmission line. So that is why it is called bus incidences. So that's why the incidence matrices are important for the developing uh, the various network matrices, because we need to develop first of all the matrices, and then after we can solve that matrices for the calculation of the power system network. Now uh, this various incidence matrices are divided from the connectivity or incidence of element to node, path and cut set of or the loop. See, basically why we need to form the bus incidence matrix, because as I explained you that this is the bus. See, this is the network, and in this network, this is the bus. Now, in this bus we have two lines. This is outgoing line, and this may be incoming line, and or we can say interconnected connection between these two generating stations. So it means they both are sharing the power. Now here only one network is drawn having three generators, but here we are talking about the large system having number of generators, or we can say infinite number of generators. So this circuit will become complex. Now for the to solve that circuit, or to find out the contingency of the power transfer, we need to convert that network into the graph, and then after we can form the matrix of particular buses, and then after we can calculate the power, means active power, reactive power, or whatever we want to calculate with the help of that matrix form. So that's why we need to form the bus incidence matrix. Now bus and incidence matrix are basically, they are classified in five different part. So the first part is element node incidence matrix, in which we consider elements and node of particular network. Then that element incidence, from that element node incidence matrix we can form the bus incidence matrix. Then after the sorry the third is branch path incidence matrix. So this indicates the particular branch path, means the direction of the current and the direction of the power in the network. Then the fourth basic incidence matrix is basic cut set incidence matrix. So by which we can divide any network, and we can solve the complex network. And fifth is the basic loop incidence matrix, so in which we solve loop by loop, means we divide any network into the basic loops, and then after we calculate the network. Now in this we have a single line diagram of a power system having three generators and three bus. So here you can see that this is the generating stations, and with G1 the bus number 1 is connected, and after bus number 1 we have the two lines. With the interconnected line, we have the two transformers, both are connected in series, T1 and T2. Then after uh, with this line, we have the T3 which is connected with the bus number 2, and on bus number 2 we have one more generator, it is G2, and the line of G2 is connected with the transformer T4, and T4 is connected with the bus number 3, and bus number 3 we have the generating station, generator 3. So if we want to convert this into the graph, so as I explained you that we indicate all the elements with the straight line or single line. So here this is the positive sequence network. So in this you can see that we indicated nodes with the circle, means this is the node at which the three lines are meeting. So 1, 2 and 3, these three are the nodes on which we have connected the bus and the transmission line, and this is the reference node, it is connected with the ground potential, and all the generating stations are connected with the straight line, means single line, so by the short circuit. Now let's solve all the incidence matrix one by one. So start with the first matrix, that is element node incidence matrix. So this elements node incidence matrix basically denoted by the uh, mode A, or we can say A bar. Now this is the graph oriented graph for which we are forming the node incidence matrix. So this is oriented graph of that previous network that we have drawn. So here you can see that this is the direction of the line is indicated. So this element node incidence matrix A shows the incidences of elements to node in the connected graph. So that means, what do you mean by what is the meaning of incidences means we are indicating, or we are solving this network by providing the direction of the lines or elements. So this direction you can select randomly, or means maybe it may be given while you solve the example in the exam. So as these directions are given, so from this the incidence or connectivity, means connectivity of each and every line in the network is indicated by the operator, means this the arrow shows it is an operator. So from that we can follow the path of elements. Now the sign convention is very important for to determine the elements node incidence matrix. So please pay attention over here, means mainly this is the main part of this element node incidence matrix. So positive if the direction of the arrow is directed away from the node. Suppose this is node number 1, and this arrow is going away with the 1. So this may be positive. And if -1 if the direction of the arrow is directed towards the node, so this direction means operator 1 is towards the node number 1, so we can take it positive. And 0 if there is no connection between the nodes. So here you can see that this element is not connected with this 2 and 3. So there is no connection between this element and between 2 to 3. So by this direction we will form the matrix. Let's see how we can we can form the matrix. Now this is element node incidence matrix for the above network means for this. So here we take the nodes. We have the number of nodes, that is 0 1 2 3. So in horizontal line we taken the node, and in vertical line we have the elements. So calculate the elements: 1 2 3 4 5 and 6. So we have the 6 elements. So we can say 6 by 4 matrix we can form with the help of this network. So in this column the elements are written 1 2 3 4 5 and 6, and this a bar indicates this is element node incidence matrix. Now we will check the relation of element number 1 with 0, means node 0. So here from 0 1 is going away. So going away, so it means it is positive. So you can see over here, so it is plus 1. Now element 1 with node 1, so element 1 is going towards 1, so that's why it is taken minus 1. Now element 1 towards 2, so there is no connection between 2 and operator 1 or element 1, so it means it is 0. There is no connection with 3, so it is 0. Let's solve it by your way. uh, Number 2, so here this is number 2. Now connection of number 2 with 0, so it is going away from the 0, that's why it is positive. Now it is operator means element number 2 is going towards node number 2. Here uh, element 2 is for 1, sorry, for 1. So element number 2 is not connected with the number 1, so that's why it is 0. Now element number 2 is going towards the node number 2, so that's why it is minus. You can see over here. Now element number 2 is means there is no connection of element 2 with element number 3, so it is taken as 0. So this is how we can form all whole matrix, and it is indicated like this. So over here you can see that 1 minus 1 0 0 taken from this, and whole columns and rows are written like this in the form of matrix. So that is called E cross N, means elements cross nodes. So this is 6 by 4 matrix we can form for element node incidence matrix with the help of this network. So this is element node incidence matrix by which we can check uh, the meeting of elements on particular node. Means we can check the contingency of the element, or we can say from that we can determine that that particular element is connected with a particular node. So and what is the relation of particular element with particular node, we can determine with the help of element node incidence matrix. So let's see the second, that is second part of the bus incidence matrix. So we can form bus incidence matrix A. So with the help of the this oriented graph, so the same oriented graph is drawn over here. So here the bus and incidence matrix basically denoted by A. So here A is written, so A is equal to, here in the horizontal line the number of nodes are taken, and here the number of bus means elements means which are taken over here. So we have the 6 elements, and this we have the 6 node. Now how we can form the bus incidence matrix? So the bus incidence matrix obtained by deleting the column corresponding to the reference node. So here in the previous diagram we taken the in the previous incidence matrix elements node incidence matrix, we have taken the reference node. Now in this, if we eliminate the reference node column, then we can form the bus incidence matrix A. And corresponding to the see the matrix obtained by deleting the column corresponding to the reference node, and the element node in the element node incidence matrix A is called the bus incidence matrix. So whenever the reference node is not considered, and if the matrix is formed, then that matrix is called bus incidence matrix. Now bus incidence matrix for the given oriented graph is drawn like this. It is same as the previous case, only one means node is not there, so that's why the column of the 0 is not there, and everything is same for the bus number 1, or we can say operator number 1 is going towards the node number 1, that's why it is taken minus. Now there is no connection of operator 1 with 2, so that's why it is taken 0. There is no connection of operator number 1 with 3, so that's why it is taken as 0. Now we'll take the direct bus number 6 means element number 6. So here check element number 6, it is going away from the node number 1. So going away node number 1, so it means positive. Now for the node number 2, so it is going towards node number 2, that's why it is taken minus. And for node number 3, so there is no connection of means there is no connection means there is no relation of operator number 6 with 3, node number 3, so that's why it is taken 0. So this matrix will become a 6 by 3 matrix when we eliminate the reference node, and we can form the bus incidence matrix. So bus incidence matrix basically describes the contingency of power on particular bus. So let's see the third incidence matrix, that is branch path incidence matrix. So branch path incidence matrix basically denoted with K. So here it is indicated with K, so K is equal to, and the horizontal path is horizontal line is path, and the vertical is branch. So how we can form the branch path incidence matrix? So first of all we will draw the tree of particular oriented graph. So here you can see that the tree is drawn. What is tree? Tree is a tree indicates the path, and the number of elements which are le- uh, uh, whi- uh, which includes all the nodes by without closed loop. So here you can see that this is the path in which we included all the nodes, node number 1, 0, 2 and 4, but it is not forming the closed path, so that's why it is called tree, and the rest of the elements are the core tree of this particular oriented graph. Now the branch path incidence matrix show the incidences of branches of the path of a tree. So the element of matrix are indicated by the operators as follows. So these are the operators. This is the path number 1, this is the path number 2, this one, and this is the path number 3. Now the sign convention for the particular path. So if the plus 1 is taken of the arrow is same direction of the path, means suppose this is the path shown over here like this one. So this is in the opposite direction. So if plus 1 when we take plus 1, it means the direction of the arrow and operator both are in the same direction, and otherwise we will take the minus 1, and 0 if there is no if the branch is not in the path, so it means we can take the 0. So let's solve it, so that will become more clear for more clear to you. So this dotted line indicates the core tree, and this dark line indicates the tree of this particular oriented graph. Now this branch path incidence matrix, so in this we have the path 1, 2 and 3. Now branch 1, so this is the branch 1. So for branch 1, the direction of the path and the operator path both are in opposite direction. So here we will take the minus 1. You can see this is the direction of path. So both are in opposite direction. Sorry, both are in the same direction, then we will take the -1. So here you can see that uh, the tree which is drawn for this, so this is taken -1. Now in this sign convention, here we have I made the typing mistake. So this is not the same, this is the opposite direction. So -1 will take when the arrow of the path in the opposite direction. So here you can see that path 1 and this operator both are in the opposite direction. So the connection between branch and path 1, so this is the branch 1 and this is the path 1, both are in the opposite direction, so it is taken as a minus. Now from this sign convention, here one thing you should add, that is this remove same and put over here the opposite direction. Now uh, uh, the branch 1 means this the relation with branch number 1 with 2, so there is no relation between 1 and 2, so it means it is taken as 0. Now branch 1 with 3, so there is no relation between 1 and 3, so it is again taken as 0. Now for the branch 2, so this is the branch 2 and this is the path, so here the path we taken like this is the path and this is the path. So here you can see that at 2 2 with 1 there is no connection, so it is taken as 0. Now this is the direction of the path, so both are in the opposite direction, so it is taken as minus. Now this is the number 3, so again both are in the opposite direction. Over here this is the arrow marked over here, both are in the opposite direction, that's why again it is taken as 0, sorry, taken as 1 -1. And means there is a connection between operator 2 with 3, but the direction of the path which is indicated for the branch path incidence matrix is in the opposite direction to the 3, that's why it is taken as minus. And for the number 3 means branch number 3 over here, so there is no connection of 3 with 1, so that's why it is taken as minus, sorry, 0. And the branch number 3 is connected with branch number 3, so there is no connection of branch number 3 with path number 2. There is no connection between path number 3 to 2, so that's why it is taken as 0. And uh, there is a connection between 3 to 3, so both are in opposite direction, so that's why it is taken as -1. So from this we can we have 3 operators, or we can say 3 path in the tree, that's why this matrix is formed 3 by 3. So this is how we can form the branch path incidence matrix. Please keep in mind the sign convention. In this we have one typing mistake, instead of this same we have the opposite direction. Please correct it, student, by it your way, by your way. Now the fourth the incidence matrix is basic cut set incidence matrix. Now the basic cut set incidence matrix is indicated created with bracket B. So here the in the previous diagram of tree and co-tree, we cut this in means we can cut this operator in 3 different part, as we know the rule of cut set. Cut set will divide any means oriented graph into 2 part. Okay, so we can cut from over here also, we can cut from over here also, and we can cut from over here also. So the direction of the cut set is also indicated. So over here you can see that this direction is indicating that the direction is in the towards the uh, node number 1. And now over here you can see that this is the direction, indicate that this is the direction is toward node number 2, but it is away opposite in the to the node number 1 for the cut set y. And for the cut set z, the direction of the arrow indicated towards the node number 3, and means it is away from the node number 2 and node number 1. So the basic cut set matrix is basically denoted by B, so that's why B is written over here. And the matrix depicts the connectivity of the element to the cut sets of the connected graph. Means this is the connected graph, and for that we are performing the cut set, so that depicts the connectivity of the element and relation between the element with each node. So first of all we'll write the direction or sign convention. For the sign convention, +1 taken if the direction of the arrow is in the same direction of the cut set. Matlab, as I explained you that this is the direction of arrow which is in the same direction of the cut set over here, so it is taken as +1. And over here this is the direction of arrow, and this is the element number 6, so you can see that both are in the opposite direction, so that's why it is taken as minus. And 0 if the branch is not in the intersection, means if there is no intersection, means there is no cut set x is not related with the branch number 3, so it can be taken as a 0. So the basic cut set matrix has the dimension is E cross B. So E are the elements we have the number of elements 6, and B is the number of basic cut set. So here we cut this oriented graph in 3 parts, that's why x y z is the basic cut sets. So the matrix forms with the help of this oriented graph, that will be 6/3. Now let's see how we can form this. So element number 1, so this is the element number 1, and cut set x, so both are in the same direction, so same direction, so this means it is taken as 1. Now element number 1 with y, so there is no connection between 1 and y, so this is taken as 0. Same as for z, it is taken as 0. You can see this. Now let's take the another element number 2. So element number 2, there is no relation between 2 and cut set x, so that's why it is taken as 0. Now this is the y, so in this y you can see that it is in the same direction, so that's why means both are going towards the node number 2, that's why it is taken as 1. Now there is no connection between z and element number 2 and z, so that's why it is taken as 0. So this is how you can solve for all the networks. Let's see for the element number 6. So this is the element number 6. For element number 6 with relation x, so both are in the opposite direction. This is the direction of the cut set which is going toward the node number 1, so that's why this will taken as a -1. Now element number 6 with y, so both are in the same direction, so that's why it is taken as +1. And there is no connection between element number 6 and cut set number z, so that's why it is taken as 0. So from this we can form the matrix like this. So this will become 6/3 matrix. So this is how we can solve the basic cut set incidence matrix. The main motive of perform the cut set in the oriented graph is to divide the network in parts, and we can solve it simultaneously. Now the fifth incidence matrix is basic loop incidence matrix. So we have already a tree and code tree graph, or we can say oriented graph. So we can check out the basic loops of particular oriented graph. So in this oriented graph you can see that we have this loop 1, this is the second loop, this is the third loop. So this is how we can form the loop. Loop indicates the close path. So basic loop incidence matrix basically indicated by the C. So this matrix depicts the incidences of the elements of the connected graph to the basic loop. Means the graph which is connected with the particular element in the basic loop. So in this loop you can see that there is no means this loop I am pointing out this loop. So in this loop there is no connection of element number 4 with this loop. So we will check the relation between the loop direction and the elements. Now sign convention. So plus 1 if the direction of the branch arrow is the same direction. So here you can see that this is the direction of the path indicated. So in this you can see that this direction of the arrow is in the opposite to the one, so that's why it can be taken as a -1. And over here suppose this arrow comes over here and closing the loop like this. So 2 and this arrow both are in the same direction, so it can be taken as a +1. And if there is no relation between branch and loop path, so loop element, then it is taken as 0. So means for this there is no connection for 4, then it can be taken as a 0. So basic loop incidence matrix we are forming with the help of this oriented graph. So oriented graph basically indicated by C. So number of branches we have 6, and the basic loops that we form are 3 loops, P, Q and R. So let's take the loop P. So in loop P, branch 1, so there is no connection of branch 1 with loop P, so that's why it is taken as 0. Now for branch 1 to Q, so here this is the Q. So 1 and Q both are in the opposite direction, so that's why it is taken as minus. And R, so in this R you can see that this is the direction, so both are in the same direction. 1 and the direction of the loop both are in the same direction, so it can be uh, it should be 1. So let's take the branch number 2. So this is the branch number 2. Now for branch number 2, the relation of branch number 2 with P, so here this is the P, so both are in the opposite direction. You can see the marking of arrow and operator marking means direction of the arrow, so both are in the opposite direction, so it will be -1. And the branch number 2 with Q, so there is Q, means the direction of the Q is in this direction, so both are in the same direction, so it is taken as 1, means +1. And the number 2 with R, so this is the R, so both are in the opposite direction, so it is taken as -1. So this is how by checking the direction of the arrow and direction of the loop you can form the matrix. So we have the 6 element and we have the 3 basic loops, that's why this matrix will form the 6 by 3 matrix, and it is called E cross L, means elements cross loops. So we have the 3 loops and we have the 6 elements, so 6 by 3 matrix we can form with the help of basic loop incidence matrix. Now this is the most important part of this chapter, means using singular transformation we can we use the network matrices for the singular transformation of particular bus and uh, branch. So the network matrices that we use are commonly in power system analysis. So it can be bus admittance matrix, bus impedance matrix. So impedances can be converted into the admittance and admittance can be converted into the impedance. Whatever we as per our requirement we can convert both into each other, and we can solve the matrix. Then this is the for the particular bus. Now we can solve for the particular branch, so branch admittance and branch impedance matrix, and we can solve it by loop, so that we it can be loop impedance and loop admittance matrix. So this with the help of the 6 matrices techniques we can transform means network, and we can transform the network in the matrix. So in singular transformation each elements of the network is represented by line, so that that we know already. Each elements we replace with the line, and then after we'll solve the network. The resulting diagram of the network is known as the graph that we already know from the previous case, and each source and shunt admittance across it taken as a single element that we already converted. Generators will converted the single line. Even the elements which are connected with the network, we can draw it a single line. And if each element of the graph shows a direction, then in this that graph is known as the oriented graph that we know from the previous case. Let's see one example related to this. So for this oriented graph, this is the direction which is showing the contingency with the elements with the node. So for this we form the tree and co-tree. So this is the tree which is including all the network, means all the nodes. So this is 1, then 4, and then 3, and then 2, and then 2 to 1. So this dark line indicates the tree branch, and the dotted line the dotted line indicate the link of the tree branch, or we can say co-tree. Now in this we can select a tree or a graph. Now in the tree all the nodes are included without forming a closed path. So here whatever the nodes we taken for the tree, it is not forming the closed path. And uh, for the graph, means we have total 9 branches. So the voltages of each branches are means that will be means we will get 9 different voltages, that is VB1 to VB9. And that can be written in terms of 4 bus voltages. So we have the 4 buses, that is V bus voltages, that is V1 to V4 of the reference node. So for this we are writing the voltage equations. So here in singular transformation of each element of a network is basically represented by a line, and the resulting diagram of the network is known as a graph. So graph of the particular network. So each source and the shunt admittance across it is taken as an element, and each element of the graph is known as the is shown as a direction. So this is the direction is shown, and it is known as the oriented graph that we know. Now the tree branches from a subset of elements. So this is this showing that from the subset of the element, it is the connected graph. uh, uh, the number of branches B required to form a tree. So we have the number of branches which is forming the tree, and that is equal number of the buses, means the number of buses we have the 4. So 4, we have the 4 number of branches in the tree. So this above system has total 9 branches. It has, so that's why it has 18 variables, and the variables are double to the number of branches basically. And however, it is easy to see that all these 18 variables are not independent. Means both are dependent, all are dependent to each other. So they are not independent variable. It is found from the concept of tree, and the tree branches given the number of independent voltages. So number of tree branches indicates the total number of voltage. So here you can see that VB1 to VB4 for the particular buses, we have the voltages of all the bus like this, and the number of tree branches equal to the number of buses, means tree branches are equal to the buses. We have the 4 buses, so we have the 4 tree branch, 1 2 3 and 4. So the number of links gives the number of independent current variable. So the links which indicates the independent current variable which are transferring from node to node. And let's solve this. So for particular branch we have the four tree branch, so that's why four tree branch voltages are VB. For VB1 it is V1, VB2 for V2, and VB3 for V3, and VB for V4. Now let's say take the branch 5. So this is the branch 5. It has the relation between 1 and 4, so that's why this arrow is going away from the 1. So this is the higher potential and this is the lower potential. That's why the voltage of this node is taken as positive. That means it is plus 1 V1, and this is the lower potential, that's why it is minus V4. Similarly for VB6, so for the branch number 6 over here, you can see that it is going away from the number 4. So it is going away from the number 4, so it is taken as a positive and going towards the number 3, that's why it is taken as negative. So V4 minus V3. So similarly we can solve for all the branches, and we can write the equation, voltage equations. We can say potential difference between each branches. So consider the current direction, current flow from higher potential to lower potential, that we already considered. So that's why that will become V is equal to incidence matrix A, bus incidence matrix A into V, voltage of particular bus. So from this equation we can form the network. Now this is the network which forms. So means the bus incidence matrix which is formed. So this is the number of buses, or we can say lines. So that is sorry, elements, it's 9, and these are the node bus elements. We have the 9 elements, so that's why it is taken as 9, and these are the nodes, means we have the 4 nodes in this. Except the we are not including 0 because reference node, because it is the bus incidence matrix. In this we will not consider the reference node. So as we know the direction of the current, so we can form the bus incidence matrix. So operator number 1 relation with node number 1, so going away, so it is taken as positive, and there is no connection between operator 1 with 2, 3 and 4, so that's why it is taken as 0. Similarly for 1 to 4, that will become the diagonal matrix, means for 1 we have the voltage V1, V2, V3 and V4. Now from this equation also we can form the bus incidence matrix. For VB5, V1 is positive, so V1 is taken as positive, and V4 is taken as negative, so here this will be -1. For VB6 it is V4 is positive, so this is the printing mistake. Either here we have the 1, and this V3 will be the -1. So these are the link branches and these are the tree branches. So for this we can form the first, the upper one is the diagonal matrix for the particular branch, means tree branches, and this is the matrix which is formed with the help of link branches. So this is how we can solve the any matlab network which is given, and that for the network we first of all will draw the oriented graph, and then after we'll find the tree and co-tree of the particular branch, and we can write the voltage equations and contingency equation for particular node to the branch. Now from this the element of A, as we already derived, bus incidence matrix is written according to the rules as incoming node from the other node. Means incoming node is negative and leaving node is positive, so it can be easily seen from the previous slide. Now formation of the Z bus into Y bus. So how we can convert Z bus into the Y bus? So as we already know that Z is equal to V upon I from the Ohm's law. So Z means matrix V is equal to matrix Z into matrix I, means current matrix I. So I will make it I make I as a subject, so I is equal to V upon Z. So I is equal to, we can say we can write this Z is a Z inverse into V. So I is equal to Z inverse can be write as a Y, because it is a reciprocal. Impedance is reciprocal of admittance, so it is indicated as Y, so Y into V. So that's why we can write Y is equal to Z inverse, so Y bus is equal to Z bus inverse. So whenever we find the Z bus, by taking inverse of that Z bus, we can find out the Y bus. Now We will see the formation of Y bus and Z bus using singular transformation in the next lecture. Thank you, student. Thank you all. Jai Swaminarayan. If you have any query and any doubt, we can solve it in our doubt solving session, and feel free to call me anytime. You have my number. Thank you very much, student. Thank you all. See, due to the limitation of the time, I am not including this point in this lecture. Thank you all.